Welcome to quantitative aptitude video on problems on trains from careerride.com. Problems on trains are very similar to problems of speed, distance and time. Just like speed, distance and time, 1 to 2 sums are always seen in placement test, job interviews and all other exams. In today's tutorial, we'll understand the train concepts and see how to easily and quickly solve all the train problems using just the basic formula. Also for practice, careerride.com has 1000 plus practice questions and practice test on quantitative aptitude for you. So let's start with problems on trains. In the earlier videos, we have learnt about speed, distance and time. If you are familiar with the concepts of speed, distance and time, if you know their formulas, then you'll understand problems on trains in just 5 minutes. Okay, there's nothing to it. It's very simple. You'll understand the entire concept in just 5 minutes. But if you are not comfortable with speed, distance, time, then I would suggest that you take a look at the video published on speed, distance, time. Over here also in like 2 to 3 minutes, I'll revise the entire concept of speed, distance, time, right, along with the formulas, and then we'll head on to problem on trains. So initially, speed, distance, time have their own formulas. There are 3 formulas, right? Now how to remember these formulas and let's understand what exactly these formulas are. So how to remember the formula? Just first of all, draw a Y. Okay, now out of speed, distance and time, generally in numericals, larger quantities are of distance like 1000 kilometers, 500 kilometers, etc. Time is 1 hour, 2 hours, 10 hours, 12 hours, like this. Even speed is 150 kilometers per hour, 200 kilometers per hour, like that. But larger quantities or larger numbers are seen for distances. So always write distance at the top, right? Then speed can be here, time can be here. You can even interchange, even this is fine. Right, distance at the top and time over here and speed over here. You can write speed and time anywhere. Okay, so let us go with this. Now what is the formula for distance? Distance is nothing but speed into time. Time is nothing but distance divided by speed. Distance divided by speed, and speed is distance upon time. See how easily a small y helps you remember the formulas accurately in exam. Whenever you go to a paper at the corner, just write this y, okay, and whenever you have sums related to trains or boats and streams or even speed, distance, time, you can simply write this y and solve, get the formulas very easily. Now let us move on to another concept of speed, distance, time, and that is what are the type of sums that may be asked. Now in speed, distance, time, the type of sums are either the distance is same or the speed is same or the time is same, right? Or there may be a sum which wants average speed of the entire journey. Only these things are asked when it comes to speed, distance, time. Now let us move on to problem on trains. Problem on trains are very similar to the speed, distance, time concept. There are only 3 elements or 3 small things which you need to remember. First, you should measure or include the length of the train in distance traveled. Okay, so whenever in speed, distance, time we had the distance, okay, we used to take the distance traveled over 45 kilometers or say 500 meters or anything like that. Now you should include the length of the train in the distance traveled. Secondly, the length of a pole, man or a car, okay, car, man, etc. is always taken as 0. If they have mentioned that the length of the car is this much meters, then only we should include the length. Otherwise, for all other aspects, length of pole, car, man, etc. has to be taken as 0. We should not consider the length. And the third one is relative speed. What is the relative speed? Relative speed means speed of one object in relation to other object. Whenever say a train is traveling at the speed of 40 kilometers per hour, so we are saying 40 kilometers per hour in relation to a stationary object, right? Someone like a person standing on a platform. But when we say relative speed, we are talking about 2 moving objects, one moving like this and other say is moving in the opposite direction, or one is moving like this and even the other one is moving in the same direction. So this is object 1, this is object 2, this is object 1, this is object 2. So speed of object 1 in relation to object 2, or speed of object 1 in relation to object 2, or speed of object 2 in relation to object 1. When we are trying to find out speeds or velocities in relation to other moving objects, then we call it as relative speed. We will take a look at this concept in detail. Okay, so you just need to remember 3 concepts for trains, that is length of train has to be included in distance traveled, length of pole, car, man, etc. has to be taken as 0, and we have to take relative speed, or we might have to find out relative speeds. Okay. Now let's take a look at what exactly is relative speed. Just like we said earlier, that generally whenever we are talking about speed of an object, we are talking about the speed in relation to a stationary object, right? This is say a car, it is moving in this direction at some speed. So, and if there is some a man is standing over here, okay, stationary man. So that man is not moving. When we are talking about normal speed, the speed is in relation to a stationary object. But say if a car is moving like this, and say another car is moving like this in the same direction, then the speed of car 1 in relation to speed of in relation to car 2 will be called as relative speed. Okay, relative means in relation to speed of one object in relation to other moving object. Whenever there are 2 moving objects, we find out relative speed. Whenever there is only one moving object and one stationary object, no need to find out relative speed, normal speed is enough. 2 moving objects, find relative speed. Now there are 2 concepts over here in relative speed and they are very easy. Let's see. Now let us assume that we have a train called as T1 and the train is moving in this direction, right? Then we have another train which is called T2 which is moving in this direction, right? Train 1 is moving at the speed of x kilometers per hour, train 2 is moving at the speed of y kilometers per hour. Okay, what will be the relative speed of train T1 with respect to train T2? It is simply given by x plus y. Now why x plus y? I'll tell you. From childhood we have learnt a very basic principle. What is it? It is called opposites attract, right? Attract means what? A. Attract A. A means what? Add. So simply add the speeds, right? Attract means A. A means add. Add means simply add the speeds, right? Now other concept is, say train T1 is moving in this direction, okay, and train T2 is moving in this direction, that is the same direction. T1 is moving with the speed x kilometers per hour, T2 is moving with the speed y kilometers per hour. Then what is the speed of train T1 in relation to train T2? Simply x minus y. Y minus y subtraction. X and y are moving in the same direction. Same means s. S means subtraction. S means subtraction. So x minus y. See, you might have seen that whenever 2 buses or 2 bikes are moving, when you go out with friends on 2 bikes, okay, there are 2 bikes, and when you are trying to drive at the same speed or alongside each other, we feel that our friends are moving very slowly or they are very stationary, okay. See, if you are sitting here with your friend, okay, the friend is driving over here, you are sitting on the back seat, and another friend is driving and there is another friend over here on the back seat, and whenever you are driving on a road very slowly or when you are going at the same speed, almost equal speeds, you feel that you both are stationary, both the bikes are stationary, because in relation to each other the speeds get cancelled. That is the reason we subtract it, right? And again, say if a friend is driving and you are sitting on the back seat and another friend is coming from this side, okay, in the opposite direction. The friend is driving, another one is sitting over here. You both will pass each other very fast. Why? Because the speeds get added. So opposite direction add, same direction subtract, right? Same direction subtract, opposite direction add. This is the only thing you need to remember regarding relative speed. Whenever trains are in opposite direction, okay, you need to add, and whenever trains are in same direction, you need to subtract the speeds, right? Now, let's move on to sums and let's see how to tackle these sums. Question number 1. Two trains with lengths 126 meters and 119 meters respectively are moving towards each other. Their speeds are 12 meters per second and 23 meters per second respectively. What will be the time needed by the trains to cross each other? Now, this is a train, okay, this is train T1 and train T2 is moving towards train T1. Both of the trains are moving. Train T1 is moving at the speed of 12 meters per second, train T2 is moving at the speed of 23 meters per second, right? Length of T1 is 126 meters, length of T2 is 119 meters. Now, what did we learn? This is a speed distance time sum, so we need our DST, okay? At the right hand side, we will write this formula. Apart from that, we must include the length of the train, okay? From here onwards, generally we will consider the length of the train as L. Okay, for everywhere we will consider length of the train as L. Okay, then we need to find relative speeds and we need to consider length of the pole or man or a car as 0, but that is not the case over here. We don't have any pole, man or car, so we will not consider this. Okay, now over here what they are saying, what is the time needed by trains to cross each other? What does that mean? Train T2 will completely cross train T1. That means if train T1 is over here, okay, train T2's last point which is there, it will completely cross T1. Also, train T1's last point will completely cross T2 because they need to cross each other completely. So, how much is the distance travelled by train T2? It is nothing but equal to the length of train T1, right? That is 126 meters. And what is the distance travelled by train T1? It is nothing but equal to the distance travelled by T2. Okay. So, we will simply add, so the total distance travelled is nothing but 126 plus 119. No other external distance is given. When two trains are, always remember, when two trains are crossing each other and if they ask how much distance is travelled by trains while they cross each other, when they cross each other, always say it is nothing but the addition of the lengths of the train. I will give another example. Say this is a pole and this is the train, okay. Now this train T, it is passing the pole. So the pole, how much distance does the pole cover from this point till this point, correct? So that is nothing but the length of the train, right? Also, we can look at it this way, that the first point crosses the pole and then the last point crosses the pole. In that, the entire train crosses the pole and goes over here. So the total distance travelled is L by the train, okay? Now, so here we know what do we want? Time needed. Time formula, time is equal to distance upon speed. Distance upon speed. What is the distance travelled? 126 plus 119. Now, do we know the speed? No. Let's see what the speed is. Now, what they have given is that trains are moving towards each other, right? One has a speed of 12 meters per second, other has 23 meters per second. What have we learned when there are two moving objects? We consider relative speed. So, this is say 12 meters per second and this is 23 meters per second. What will be the relative speed? X plus y, that we have seen. Opposite, add. Opposite, add. So, x plus y, that would be 12 plus 23 equal to 35. 35 meters per second. So, this would be 5, 6, 4, 3, 4, okay, 245 divided by 35. Let's see, 7. 5 4s are 20, 45, 49, that would be equal to 7 seconds. So the trains cross each other in just 7 seconds. See how easy it was. You just need to remember two moving objects, find relative speed. It is a simple speed distance time sum and you need to consider the length of the train in the distance travelled. These concepts would become more and more clear once you solve further sums. Let's see question number 2. A train passes a stationary pole in 8 seconds. The train also passes a 200-meter long bridge in 28 seconds. What is the length and the speed of the train? Now, since it is a speed distance time sum, we will have our DST written over here. We will also remember that we must include the length of the train in distance travelled, then length of the pole, length of the car, man, etc. has to be 0 and we have to consider relative speed. But relative speed has to be considered whenever there are 2 to 3 moving objects, 2 or more moving objects. Are there any moving objects over here? No, only train is moving. The pole is stationary, bridge is stationary, so no need to consider relative speed. We will take the normal speed. Okay, now over here what they have given, there is a train. Let us say this is the train T. Now there is a pole over here, right? This is the pole. The train passes the pole. What does that mean? The pole crosses the entire train. That is, let us assume that the length of the train is L. So how much is the distance traveled by the train or the distance traveled by the pole while crossing each other completely? That would be L. Correct? This would be the first case. Now there is a bridge, okay, and the train is passing the bridge. Now the length of the bridge is 200 meters and length of the train is L. How much would be, when passing a bridge of 200 meters, how much would be the distance traveled by the train? But obvious, 200 meters? No, wrong. It is 200 meters plus, it is 200 meters plus length of the train. What did we learn? Okay, what did we learn? That length of the train has to be included in the distance traveled, right? Always remember this point. In cases of trains, okay, in cases of trains, the length of the train has to be included into the distance traveled, right? So in second case, the distance traveled is 200 meters plus L. That is the length of the train. Okay. Now let's see over here what have they given. Time taken is 8 seconds, 28 seconds, so time is not same. Okay. Now speed, distance, time, we saw that there are 4 types of sums generally asked. One is average speed. We don't need average speed over here, so no. So either distance is same or speed is same or time is same. Out of that, time given for one case is 8 seconds, other case is 28 seconds, so time is not same. Then distance, in first case distance traveled is L, other case it is 200 meters per L, so plus L, so distance not same, so the speed has to be same. Let's see how speed is same. We see that it is the same train and it is passing the pole as well as the bridge. They have not mentioned whether the speed changes or not, so the speed has to be same. So S equal to S. So what will we get? What is the formula for speed? Distance upon time. Distance upon time. From where we got the formula? From our Y. Speed equal to distance upon time. Right? So here distance in first case is L. Distance traveled is L in case of the pole and the time taken is 8 seconds. In case of the bridge, distance traveled is 200 meters plus L and time taken is 28 seconds. Right? Let's solve it. What do we get? 28L equal to 1600 plus 8L. 20L equal to 1600, L equal to 80 meters. Right? So the length of the train is 80 meters. Then what would be the speed of the train? Put it into any of the formula. You can put it over here also. You can put it over here also. Let's take this one. Okay. Speed is nothing but distance upon time. Distance traveled is L, length and time taken for the pole is 8 seconds, right? Speed would be, what is the length of the train? We know 80 divided by 8, that is 10 meters per second. Why did we take meters per second? Because the distance L is in meters and time given is in seconds. So the speed of the train is 10 meters plus per second. See how easy it was. There is nothing to it. This is very similar to speed, distance, time concept, and we just need to include the length of the train into the distance traveled. You go through, if you have not gone through speed, distance, time, go through that video and you will be able to understand these sums pretty much faster. Okay. Moving to question number 3. A train having length 150 meter passes a platform of 550 meter length. The time taken for it is 56 seconds. In how much time will this train take to pass the platform of 250 meter length? Again, this is similar to the previous sum, that is question number 2. Let's solve it. Let's see how to do it. It is a DST. We should consider length of the train and length of the platform, etc. is given. Okay, over here. Now, is it an average speed sum? No. Is the time taken same? No. That we have to find out. So right now time taken is not same. Then is the distance traveled same? No, because the platform lengths are different. So the speed must be same because it is the same train, right? So we have speed equal to speed. Speed is nothing but distance upon time. That would be distance upon time. From where we got this formula? From here, RDST, right? In the first case, how much is the distance traveled? That would be length of the train plus length of the platform, right? we have learned that whatever is the distance traveled, we must include the length of the train into it. Now what is the time taken? Time taken is 56 seconds. In the second case, length of the train is 150 and length of the platform is 250 meters. And time taken is, we do not know, we have to find. So let us take it as T. What do we get? 550, 600, 700 by 56 would be 300, 400 by T. 7 into 100, 7 into 8, this is 4. So we have T equal to 32 seconds, right? See how easily, how quickly we got it. In exam, if you practice, you will be easily able to solve these kinds of sums in 35 to 40 seconds. Maximum 1 minute. If there is some complex sum or something like that, maximum you will take 1 minute. But on practice with such basic formula and such quick analysis, you will be able to solve this sum in just 1 minute, under 1 minute. Moving to question number 4. Stations M and N are 276 kilometers apart. At the exact same time, a train starts from M and other from N towards N and M respectively. These trains meet after 12 hours. The train traveling from M to N is slower by 14 kilometers per hour in comparison to the other train. What is the speed of the slower train? Now what they are saying is that there are two stations, M and N, right? Now as usual, this is a speed distance time sum. This is very easy. If you just draw this line diagram, you will very easily understand what is going on. What they are saying, M and N, they are 276 kilometers apart. At exact same time, a train starts from M, say it is T1, and train starts from N, say it is T2. They start at the same time, okay? They both travel for 12 hours, right? So after 12 hours, let us assume that they meet at this point after 12 hours, after traveling for 12 hours. What does that mean? Both of them are traveling for the same time period. So the time period is same for both case. T is same, right? Now, what have they given? That they meet after 12 hours, right? And the train traveling from M to N, this one, T1 is 14 kilometers slower, okay? So that means T2 is 14 kilometers faster than this train. So let us assume that speed of T1 is x kilometers per hour. That is the train moving from M to N. So T2 will be x plus 14 kilometers per hour because it is 14 kilometers per hour faster, right? This is the speeds, right? Speed for train T1, speed for train T2. We have the speeds, we know the time is same. Now what they have given is that the distance total, what is the speed of slower train, that we have to find out. Now total distance they have given as 276 kilometers. Now whenever the two trains meet, say at this point they meet, distance traveled by the first train plus distance traveled by the second train is nothing but 276 kilometers, correct? Same way that concept we will use over here. Distance by first train plus distance by second train is nothing but 276 kilometers. Now what is the distance traveled by first train? Distance is given by speed into time, correct? How much is the speed of the first train? X. What is the time? 12 plus, okay? What is the distance? What is the speed of the second train? X plus 14. What is the time? 12. That would be equal to 276. So we have 12x plus 12 into x plus 14 equal to 276. Let us divide by 12 throughout. This gets cancelled and here we get 12 2s are 24, 36, 23. We will have 2x plus 14 equal to 23. That would be nothing but 2x equal to 23 minus 14, that would be 9. X would be equal to 4.5 kilometers per hour. This is the speed of the slower train. See how using common logic or common sense we were able to find the answer. Just draw this line diagram and we were able to deduce that distance travelled by the first train plus the second train is nothing but the total distance. Simply put the formulas for, as per the speed, distance, time and solve the question to get the answer. Question number 5. From P and Q, two trains start moving towards each other at the same time. Their speeds are 120 km per hour and 100 km per hour respectively. When the two trains meet each other, one train has covered 40 km more than the other train. Find the distance between P and Q. Now there are, again, draw a line diagram. This is P, this is Q. Okay, this first one is P. A train starts over here T1, other train starts over here T2. Speed of say T1 is 120 kilometers per hour, right? 120 kilometers per hour. Speed of T2 is say 100 kilometers per hour. Now what they say is that whenever the two trains meet, let us assume that the two trains meet at this point. Okay, when the two trains meet, one train has covered 40 kilometers more. Now let us analyze it by common sense. Let us assume that the trains are traveling for 1 hour. How much distance will T1 cover? T1 will cover 120 kilometers, right? How much distance will T2 cover? T2 will cover 100 kilometers, because their speed is 120 kilometers per hour and 100 kilometers per hour. What is the difference of the distance? 20 kilometers. That is, T1 travels 20 kilometers more, correct? Now let the trains travel for 2 hours, not 1 hour but 2 hours. T1 will cover how much? 120 kilometers plus 120 kilometers, that is 240 kilometers. T2 will cover how much? 100 plus 100, 200 kilometers. What is the difference between the distances? 40 kilometers. That means T1 covers 40 kilometers more than T2. That is nothing but our given condition. What does that mean? The trains meet each other after 2 hours of traveling, right? They have said that the two trains meet each other, but they are not given after how many hours. See, by just observation and common logic, we found out that after 2 hours the trains meet each other, because it is only after 2 hours that the distance covered between the two trains, the difference of distance covered is 40 kilometers. So if the trains are meeting after 2 hours, what we have to find? Distance between P and Q. Let the trains meet at this point. Okay, this point. Okay, the trains meet at this point. Now P has covered this much distance, Q has covered this much, train T1 has covered this much distance, train T2 has covered this much distance. This distance plus this distance is nothing but the distance between P and Q, correct? So what we have, distance by train T1 plus distance by train T2 is nothing but distance between P and Q, that is distance PQ. Is that right? And what is this distance? This is nothing but the distance travelled in 2 hours, because they both of the trains meet after 2 hours. So at this point T1 is over here, T2 is over here. So both the trains meet after 2 hours. So distance travelled in 2 hours by T1 plus distance travelled in 2 hours by T2 is nothing but the distance between P and Q. So how to find distance? We know our favorite formula, DST. Distance is speed into time. What is the speed for the first train? 120. How much time does it travel? 2 hours. Plus what is speed for the second train? 100. How much time does it travel? Again 2 hours. That would be distance between P and Q. This is 240 plus 200, it is 440 kilometers is nothing but the distance between P and Q. See, by common logic and by DST, which is speed distance time formulas, we were able to solve the sums on trains. Moving to next question. Two trains A and B leave Kolkata for Sikkim at 8 p.m. and 8:30 p.m. respectively, and run at 90 kilometers per hour and 120 kilometers per hour respectively. At what distance from Kolkata will the two trains meet? Again, this is a very easy sum. This is simply a speed distance time sum. We will have DST as usual, and over here let's draw our line diagram. We have Kolkata over here, right? And the trains leave for Sikkim. They want to reach Sikkim. Okay, this is Sikkim. Now there is two trains, A and B. A leaves at 8 p.m. B leaves at 8:30 p.m. Okay, speed of A is 90, speed of B is 120. Let us assume that both the A leaves at 8 p.m. After half an hour, B leaves, and both of them meet at say this point over here, right? Before Sikkim, at this point they meet. Here A also comes and B also reaches. Okay. Now over here, what are the type of sums which we see in speed distance time? Either speed is same or distance is same or time is same, or we have to calculate average speed. Is there any concept of average speed over here given? No. So no need to consider it. Is the time same? One starts at 8 p.m. other starts at 8:30 p.m. so time is not same. Is the speed same? No. Is the distance same? Let's see. A starts from here and meets B over here, so distance travelled by A is this much, right? This much. B also starts from here and meets A here, so distance travelled by B is also this much. So distance is same. So what do we have over here? We have d equal to d. Distance is nothing but speed of A into time of A, and this is distance for B, speed of B into time of B. Now, do we know the speed of A? Yes, 90. Do we know the time of A? No, we do not know how much time does A take to travel from this point to this point. So what do we do? Let us consider that A takes T hours, okay, to travel from Kolkata to this point, right? So time taken by A is T hours, right? Speed of B is 120, that we know. Time taken by B. Now B starts half an hour late. If B is starting half an hour late, that means time taken by B must be half an hour less. Half is nothing but 1 by 2, that is nothing but 0.5, correct? So train B, which is there, it will take half an hour less to reach this point, right? So what do we get over here? 90t equal to 120 into t minus 0.5. This gets cancelled. 3 3s are 3, 4s are. So what do we have? Let's see. We have 3t equal to 4t minus 2. So t equal to 2 hours. So time taken by A to travel from this distance to this distance is 2 hours. That is, both the trains meet after A has traveled for 2 hours, right? So now over here we have to find distance from Kolkata where they meet, right? So how much distance is traveled by A in 2 hours? Distance would be speed of A into time of A. Speed of A is 90 kilometers per hour. Time traveled by A is 180 kilometers. So distance is 180 kilometers. So at this point is 180 kilometers from Kolkata, right? So from Kolkata at 180 kilometers, both the trains meet each other. A train overtakes two boys who are running at the rate of 8 kilometers per hour and 16 kilometers per hour in the same direction as the train. The train completely passes them in 36 seconds and 40 seconds respectively. What is the length of the train? Again, very easy. This is our DST. We have to remember that we have to consider the length of the train. Then the length of the boys or man or car or a pole is 0 meters. And we have to consider relative speed. Why do we consider relative speed? Because objects are moving. Here the train is passing boys, the boys who are running. They are not stationary boys. Since they are moving, we have to consider relative speed. So we cannot directly take the speed of the train. We have to take the speed of the train in relation to the first boy. Then in second case, we have to take the speed of the train in relation to the second boy. Okay. Now let's see what are the type of sums in speed distance time. There is average speed sum, but average speed is not asked, so don't consider it. Is the time same? No. 36 seconds, 40 seconds, it's different. Now, is the speed same? In the first case, the speed of the train in respect to boy 1 would be different, and speed of the train with respect to boy 2 would be different. So speed is not same. Distance, yes, distance is same. Why? Whenever you say if this is a train, length of the train is say L, okay, this is the train and this is a boy, right? So the distance traveled by the train while crossing the boy is nothing but the length of the train. Same way, if there is another boy, the same train, if it is crossing this boy, the length would be nothing but, or the distance traveled would be nothing but the length of the train. So we have distance equal to distance. In both the cases, for both the boys, the distance traveled by the train is same. So what is distance? Distance is nothing but speed into time. Here we have seen in our y, speed into time. So speed in the first case multiplied by time in first case equal to speed in second case multiplied by time in second case. Now, do we know the speed of the train? No. So let us assume that the speed of the train is s kilometers per hour. Okay. Now, can we directly take the speed of the train? No. Why? Because here the boys are also running. So we have to consider relative speed. So relative speed or the speed, relative speed of the train or speed of the train in relation to boy 1 or the first boy is nothing but s minus 8. Why s minus 8? Let's take a look. This is the train. This is the first boy. The boy is moving in the same direction as the train. Same means subtract. Same means minus. Same means x minus y. So since it is the same direction, we subtract the speeds. So s minus 8 multiplied by time taken is 36 seconds. Speed is given in kilometers per hour. We have taken kilometers per hour. So convert these seconds into hours. Seconds to minutes, how do we do it? Seconds to minutes, just divide by 60, we'll get these minutes, and these minutes, how to convert it into hours? Again divide by 60. Okay, once you divide by 60, that 60 would come over here, so it would be 36 divided by 60 into 60. Second case, again speed, the second boy is also moving in the same direction, so speed has to be subtracted, multiplied by time taken 40 seconds, seconds into minutes, second and minutes into hours. This gets cancelled out. What do we get? 4 into 9, 4 into 10. We have 9s minus 72 equal to 10s minus 160. So we'll have S, this is 10s, okay, S would be equal to 88 kilometers per hour. This is the speed of the train. If this is the speed of the train, let us try to find out the length of the train. Length, how to find out length of the train? That is nothing but the distance travelled, correct? We know distance travelled is nothing but the length of the train. So length of the train is nothing but distance travelled, that is nothing but, we can put the value of S in this equation or this equation. You can take any one. Let us take the second one, S minus 16, 88 minus 16 multiplied by 40 divided by 60 into 60. What do we get over here? 62 into 40 divided by 60 into 60. This gets cancelled over here. 4 into 15, okay. So here what do we have? 15, that would be 62. No, this would be 72 actually. This is not 62, this is 72. 72 into 40 divided by 60 by 60, right? So 72 divided by 15 into 6. 6 12s are, so we'll have 12 upon 15. 3 4s are, 3 5s are, this is 0.8 kilometers, right? So the length of the train is 0.8 kilometers. That is nothing but, let's see, I'll write it here at the center, 0.8 kilometers, that is nothing but 800 meters. So the length of the train or the distance travelled is 0.8 kilometers or 800 meters. Moving to next question. Question number 8. With stoppage, the speed of the train is 36 kilometers per hour. However, without stoppage, it is 40 kilometers per hour. Find out how many minutes does the train stop per hour. Now again, this is very easy and can be solved by common logic. Let us say that the train travels for 1 hour. So if it is stopping, right, how much distance will it travel? 36 kilometers, right? If it is not stopping, how much distance will it travel? 40 kilometers. So what is the difference of the distance? 4 kilometers. That means because of stopping, the train is losing or wasting 4 kilometers. Now let us see how much actually time does it waste. We know it is not going, it is lagging behind by 4 kilometers, or it is wasting 4 kilometers. Let us see how much time it is actually wasting. We know speed, distance, time, DST. What is the formula for time? Distance upon speed. What is distance? 4 kilometers, right? Now speed, which speed should we take? Should we take 40 kilometers per hour or 36 kilometers per hour? We must take 40 kilometers per hour for calculating. Why? Because wastage is calculated as per, according to or in relation to ideal speed, right? Stopping, because of stopping, the speed becomes 36 kilometers per hour. That is not ideal. That is not good because we are losing 4 kilometers over here. But if we do not stop, the speed becomes 40 kilometers per hour. That means we will be gaining 4 kilometers, we will be on time. So that is good thing. That is an ideal thing. So always, whenever we have to calculate wastage or something like that, we have to take out, we have to consider the ideal speed or good speed. So we take 4 kilometers divided by 40 kilometers per hour, that would be 1 by 10 hour. So if 1 hour has 60 minutes, 1 upon 10 hour has how many minutes? That is nothing but 60 divided by 10, that is 6 minutes. That means the train is wasting 6 minutes every hour. That is, the train stops for 6 minutes every hour. See how easy it was, just common logic was used and formula DST. Going to question number 9. There are two trains P and Q moving in same direction. They are of equal length and cross a stationary pole in 5 seconds and 6 seconds respectively. In how much time would they cross each other? Okay, again this is a very easy sum. We know it is a speed distance time sum, right? And since it is a train problem, what we must consider? Length of train, then length of the pole must be 0, and we must consider relative speed. Why? Because we have to find the time taken by them to cross each other, and both the trains are moving. It is not the time taken to cross the stationary pole, it is time taken to cross each other, that is moving objects. So we have to consider relative speed. Now what we have to find? Time. What is formula for time? Distance upon speed, correct? So speed, can we take directly? No. What do we have to consider? Distance upon relative speed, that is relative speed, that is the speed of both the trains with respect to each other. Now let's find distance and let's find speed, then divide and let's get the time. Now distance, when there are two trains, say this is P and this is Q, both have same length. Do we know the length? No. So let us assume that length of P is L, length of Q is also L. Whenever they are moving in same direction, so when they cross each other, how much is the distance traveled? Simply length of P plus length of Q, that is nothing but L plus L, that is 2L. So this is nothing but the total distance traveled. So now we have the value of D. Now let us find out relative speed. Now what is the speed for train P? How to find out? Speed is nothing but distance upon time, right? Do we know the distance? How to calculate speed? Now what they have given is that the trains are of equal length and cross a stationary pole in 5 seconds. So this is a train P and there is a pole over here, right? Now this train P of length L crosses this pole in just 5 seconds. Okay, so how much is the speed of the train P? Very simple, distance traveled is nothing but length of the train and time taken is 5 seconds. Same way over here, right? Speed for train P is nothing but distance traveled is L divided by time taken to cross the pole is 5 seconds. From this we got the speed of the train P. Same way speed for the train Q would be distance traveled upon time taken. Distance traveled is L because length is same, time taken is 6 seconds. So we got both the speeds. Now what is the relative speed? Since both of them are moving in the same direction, same means minus, subtract, same means subtract. So speed will be SP minus SQ. You can take SQ minus SP also, you will just get a negative sign that you need to discard, not to consider. But let's over here take SP minus SQ. So what is the relative speed now? That would be L upon 5 minus L upon 6. Now let us find the time. Time taken is nothing but 2L, that is the total distance upon relative speed. L by 5 minus L by 6, that would be 2L upon, let's take the LCM as 5 into 6 is 30. Here we have 6L minus 5L, that is 2L upon L upon 30. L gets cancelled, this becomes 60. So here we have 60 seconds as the time for the trains to cross each other. See how easy the sums or problems on trains are. They are nothing but the sums on speed, distance and time, and you just need to consider these three possibilities. Using this you can easily solve any sum related to problem on trains. Just remember DST and consider the length of the train in distance traveled, length of pole, stationary man, stationary pole, man, car, it should be 0, and consider relative speed for moving objects. For stationary objects, no need to consider relative speed. For moving objects, consider relative speed. With this, we come to the end. So if you liked the video, please give it a like and share it with others. You can also leave your comments and suggestions. Do let us know if you have some topics in mind and we will develop videos on them for you. Subscribe to our channel and stay updated for more such tutorials.